Greetings again. This is Dr. Nathaniel Doherty with another teaching tip. This time it's a Wednesday teaching tip. This video provides some instructional design recommendations based on the theme of limited working memory, a topic related to the concept of humans' limited cognitive capacity. These recommendations proceed from the work of cognitive scientists like Dr. Richard Meyer, working within the fields of teaching and learning. In the orange and green boxes on this slide, you can find two examples of how teachers design courses in ways that respond to the limitations of working memory. What cognitive scientists like Meyer have consistently found is that the memory we can use to respond in the moment to process new information, which they call working memory, is limited, especially in situations in which we don't have much related prior knowledge to back up our working memory. This is why I can listen to a panel on post-humanist literary tropes and contemporary American fiction and come away glowing with ideas that I can't wait to discuss at the first possible opportunity, and someone who hasn't used the term trope professionally in a couple of years will probably zone out halfway through the talk. My prior memory, that is years of teaching and the PhD getting process, is supporting my limited working memory. And the other listener in this example doesn't have that prior memory to support their working memory, and so they reach the end of their capacity. Outside of the field I was trained in, my capacity to respond to that new information would be similar to anyone else's. So the first example I'll talk about is scaffolding in the orange box. Scaffolding within your courses supports limited working memory. When you know that your students don't likely have a great deal of experience with a tool or a topic that you're going to use, even a fraction of your class, you probably work to scaffold those specific elements. Scaffolding is effective from the perspective of cognitive science, partially because it builds prior memory, and prior memory can then support working memory for dealing with subsequent information. The green box, spatial continuity with reference to information layout, is the next topic. And I'll spend more time talking about this one because I imagine it's a little bit more different from what we've heard before. Certainly it was newer for me when I learned about it. So spatial continuity refers to the visual spacing and how it's a concern for working memory as well. Having students move through multiple screens or large unused spaces in an online course, for instance, will put a higher demand on their working memory. A way to avoid this is to lay out your important information so that elements are discrete, clearly delineated from each other, and clearly related to each other in terms of space. This is part of what teacher training means when it recommends chunking of information. This type of design helps students easily perceive and use the organizing logic that you have put onto the page. Otherwise, that logic can be lost. Here's an example. If you're trying to teach the relationship between several parts of an initial process, the relevance of the spatial continuity of your diagram for working memory means that an orderly, clearly differentiated, and spatially connected delivery of information, like the one we can see on this slide, will be more effective than what we can see in the following slide. So, example one, a diagram that's friendly to working memory. Example two, the first diagram, where you have all the elements together in one image, is going to work better for your students than the following spatially separated approach that I'll demonstrate now. Same information content, represented very abstractly, of course, but a very different layout. Second step, third step, and then the desired result. The spatial continuity principle can also be applied to delivery of information. Whenever possible, embed information you want students to know into a course page or email instead of placing a link to another page or screen. Another way of looking at this would be to consider whether a link to a SharePoint site containing a document is preferable to a document attached to that very same email. In a situation where you only need to consider this specific document, most of us will prefer to have the document attached to the email directly or embedded within it. This preference can be understood to reflect the spatial continuity principle as it affects our own limited working memory. Similarly, This is why a 1 or 2 page assignment sheet is preferable to a multi-slide PowerPoint presentation for delivering details of a complex assignment. If students can see all of the main details of an assignment clearly on 1 or 2 pages related to each other, their working memory will be better able to hold on to each detail and the relationships between the detailed parts of the assignment. So that's just a little bit of a cognitive science approach to designing elements of your course. Here are some references for the topics I discussed. I didn't have any direct quotations, but each of these is a good resource for learning more about working memory and cognitive science and teaching and learning in general. The link at the bottom, which I'll place into the email that distributes this video, will take you to a pretty well-directed website that can give you a more complete but still fairly concise introduction to the concept of working memory and cognitive load in general as it relates to teaching and learning. Thanks very much. Hope you're having a good week. See you next time.